Hello everyone, this is Christopher Nuñez, and today I'm going to present the research made with Regalado. This article has the following title, that is Algorithm Development for Automatic Detection of Forensic Damage in Tunnel Cross-Sectional Geometry. So I would like to start with the introduction that is here, and I write down the following three keywords, that is tunnel stability, traditional monitoring, and remote sensing technologies. So basically, tunnel stability, or stability indeed, what represent one of the most important problems in construction projects. So especially when we are talking about tunnel, the environment around that project could probably face issues or problems related with the rock masses, soft rocks, and that kind of rock. And the traditional monitoring that actually when the company present or show me what are the situation of that kind of project, traditional monitoring represents the only part of the the other another part of the big problems, or the group of problems that has different kind of projects. So because when you try to get information of tunnels, you have to, I mean, if we are talking about traditional way, so you have to go through along the length of the tunnel and try to get each meter, try to take photos, try to take videos, or try to take notes about how is the situation of that part of the tunnel. So that represents costly, time consuming, and obviously risk. So the other keyword is remote sensing technologies that we all know what is LiDAR, TLS, photogrammetry. So in this case, we use TLS because we try to get information what the project use in terms of point cloud. So as you see on the left image, we use Trimble devices. So that's why we our objective was proposing an algorithm designed to analyze tunnel damage using point cloud data captured by a TLS over 3 different years. So when I joined to the team, I found that there were another database that is related with difference years. So this is the case of study. Well, the tunnel is in the Peruvian jungle. The function of this tunnel is gas pipeline corridor. And the shape of this tunnel is vertical walls with an arc roof. Basically, it has a height of 20, more than 2 meters, and almost 2.5 meters of width. So as I mentioned, when I joined 20 team, I found different database that is related with different 3 years. 2019, that was taken using Leica. 2022, again Leica, and last year was taken using Trimble. So we have before the data acquisition process, we have to plan how will be that process. So we noticed that the tunnel has a line of 300 meters. So we decided to take or the station expanding will be every 5 meters. So try to capture all data as much as possible. So the height was one of the biggest problem, because if you reduce the height or the scanner height, probably will affect the some areas that won't be able to being captured by especially by the behind the bicycles. As you see on the image, the bike has a big diameter, so it will be difficult to actually it was difficult to try to find the ideal height. So we use like natural and artificial. So this is the main part of the project, that is pre-processing. As all projects that has a point cloud as a main source, we have to use an outliers approach, deleting outliers, try to reduce the noise and get a down sample from the raw point cloud. So as you see in the middle image and on the left image, there is a pipe. So when you acquire the point cloud, you will see that pipe. So you have to find a way how to edit. But delete the pipe and the the floor is part of the processing, not from the pre-processing. The pre-processing only works with outliers, noise, and those seven. I mean, we use Open3D as the main library using library of Python. So Open3D offers many approaches to delete outliers, reduce noise, all of them related with DBScan or another kind of algorithms that is related with point cloud. So the main task for me, I mean, from my perspective, the most important part of point cloud management is pre-processing. Then you will find a way to process and get the information that you need. So remove pipes, we try to, we create the line along the length of the tunnel. So you see here that, I don't know if you see it, okay. There is a black line, so that represents the middle or the center of the tunnel. So creating a circle around the line, you can delete the internal or the parts that are inside the tunnel. So, and using that line, you can create XY coordinates and that get the cross section. And finally, the contour profile of each of the three main database. So basically, you see on the left, you will see the contour of the 2022, and on the right, you see the three contours of this. In this case, I only put the following image that is 23. We create sections every 10 centimeters. So in less than, almost probably 10 minutes. So that was the main, or what that was the aim of our research. How do you automate that process? Because before I joined to Demi, the company usually get the point cloud, but how you process the kind of information. So basically, they mentioned that they used to try to or using AutoCAD, I think, get the information of every section, and usually take more. Usually that part of the project takes more than, I don't know, 2 or 3 weeks. So that is the aim of our approach, that is automate that kind of process. So the other part of the project is how you will see the area of each section along the length of the tunnel. So you see the area of the cross section is reducing around the years. Because probably, the information probably will tell you why is this happening. Well, you can analyze using another kind of technologies. So why is reducing the area should be a very good question to the other part of the project, because probably because the movement of the air, or probably earthquakes or something like that. So this is our result, or our main result, or main aim. So the conclusion and discussions, TLS has proven to be a reliable tool for capturing data. Analysis of the tunnel profile revealed that, if the results indicate a decline of almost 1% from the 2019 to 2024, and a systematic rightward shift in the tunnel's cross-section was observed over time. This movement underscored the need for continuous monitoring, because you have to continue to identify and address protection in instability risk, was shared with the lateral displacements, because here you see there is, if you see using millimeters, you will see the difference movements each year. So this is our presentation, and thank you very much.